Welcome to Study Loop.
Hi everyone, so what we have is a table of measured densities in the atmosphere that have corresponding heights and radius. We know that the radius of the Earth is 6,377 kilometers, and we know that the thickness of the atmosphere is 25 kilometers. What we're asked to solve for is the density of the atmosphere at a height of 7,000 meters and the total mass of the atmosphere. So one of the things that we can do is actually using all this tabular information is we can go ahead and plot it and do a curve fit in the form of that rho as a function of z is a plus bz plus cz squared. So basically a quadratic fit. And when we see is that after fitting this data, we see that these parameters are such that rho of z is equal to 1.203 minus 0.1017z plus 0.00224 z squared. Now, this is in the units of kilogram per cubic meter. So when we do this for a height of 7 kilometers, this would give us a density such that rho of 7,000 meters is equal to 0.6 kilograms per cubic meter. And the way we solve for that is we basically plugged in 7,000 meters for z in this equation. Next, what we're asked to solve for is the mass of the atmosphere, and the way we can do that is through integration. So we can say that the mass will be equal to the integral of the density over a differential volume, and we can go ahead and say that this is going to be equal to the integral from z equals 0 to h of rho 4 pi r0 plus z squared dz. And now that's just going to be basically a differential sphere that is increasing in altitude. We can go ahead and pull out some constants in this integral and expand upon some terms and say that this is equal to 4 pi from z equal to 0 to h of a plus bz plus cz squared times the quantity r0 squared plus 2r0z plus z squared dz. Now we just got this from expanding this term here. And what we see is from carrying out this integral, we plug in that formula we had for rho, so plug in for these constants a, b, and c. And we know that the radius of the Earth, this should be r naught squared, is 6,377 kilometers. And we are integrating with respect to z. So what we see is that after following through with this integral, we get a total mass equal to 5.092 times 10 to the 18 kilograms. And that's our final answer.